Okay, sulfonation. What is needed for sulfonation? For sulfonation, you need concentrated H2SO4, or you can get fuming sulfuric acid. Fuming sulfuric acid is a solution of SO3 in H2SO4. So solution of SO3 in H2SO4. So either one of these should work. But if you're using concentrated H2SO4, you should heat up the reaction. H2SO4, when reacted with together, it's going to form the benzene sulfonic acid. Okay, let's go on to the generation of electrophile. It's going to actually follow the same trend as for the generation of NO2 plus. Okay, so here instead of HNO3, we are just going to use H2SO4. Okay, so there are two molecules of H2SO4. One is going to act as a nucleophile and the other one is going to act as an electrophile. So you can see that these electrons that is on oxygen is going to go attack on the hydrogen of the second molecule, and that's going to thrust the electrons onto oxygen, and here the base is created, which we might need in the later steps. Okay, and by doing so, it's actually getting converted into a good leaving group. The leaving group right here is water, similar to the one that is synthesized in the nitration reaction. And since water is going to leave, this part is going to be the electrophile. So that's the electrophile. Okay. But this electrophile is also going to be in resonance with sulfur trioxide and the acid. Let's go on to the mechanism. The mechanism is going to follow exactly the same trail as that of nitration. So you take the electrophile, and the first step, it's going to get converted into a carbocation. Okay, so these electrons are going to come up here, and the SO3H will get added into one of the carbons where the double bond was initially. And in the next step, the base is going to go abstract this hydrogen right here and thrust in these electrons to form the double bond. Okay, so here is the product. Okay, and again, this base could be either the water molecule that is generated, or it could be the HSO4 minus, which is generated in the first step of the generation of electrophile. Sulfonation. There are two things that you have to know about sulfonation. First is sulfonic acid is a strong acid. Okay, let's draw the structure of sulfonic acid here. So we know that this is the structure this is sulfonic acid, but then when you actually draw the structure, complete structure, then it's going to look like this. Okay, this has a pK of minus 6.5, which is going to be like super acidic. Okay. So when this hydrogen is lost, it's actually going to convert it into a conjugate base, which is going to be in resonance with different resonance structures. So this is the conjugate base that is generated from benzene sulfonic acid. Again, it's going to have many resonance structures because these electrons can hop in and create and the electrons can go either onto this oxygen or it can go onto this oxygen, and those electrons can come back here again and have different resonance structures. So this is called as benzene sulfonate ion, which is stabilized by different resonance contributors. And the next thing that you have to know about the sulfonation is it is reversible. So when the sulfonic acid, benzene sulfonic acid, is heated in the presence of an acid at 100 degrees Celsius, you will get back the benzene. It's desulfonated, and you will get back the sulfur trioxide and the acid. Remember, H2SO4 is the acid that you use. You will get back the H2SO4. Okay, so this is all about the electrophilic aromatic substitution reaction of halide